सुनी हकायत हस्ती तो दरमियाँ से सुनी, ना इब्तदा की ख़बर है ना इंतहा मालूम। बट व्हेन इट कम्स टू साइंस, इस्टेब्लिश्ड साइंस, तो हमें किसी हद तक इब्तदा की भी ख़बर है और इंतहा का भी कुछ ना कुछ अंदाज़ है, यानी द बिग बैंग, द बिग क्रंच एंड सो ऑन। जब बिग बैंग की बात करते हैं तो हमारे ज़हन में टी इज़ इक्वल टू ज़ीरो, यानी वक्त का नुक्ता आगाज़ सामने आता है, मगर उससे पहले क्या था, कुछ था भी या नहीं, और ये सारा मादा कहाँ से आया, ज़मानो मकान, टाइम एंड स्पेस एंड दिस एंड दैट। और ये सफ़र हमारा साइंस में जारी रहता है आइंस्टाइन की जनरल थ्योरी ऑफ रिलेटिविटी और इससे आगे तक। ये बहुत दिलचस्प सफ़र है, मगर इसमें वक्त के बारे में बहुत सी पुरस्रारियत और बहुत से मुश्किल सवालात भी जन्म लेते हैं। आज का मौजू है क्रॉनिकल्स ऑफ इटर्निटी। आप मेरी बैक पे, ये बोर्ड पे भी देख सकते हैं, अनवेलिंग द टेपेस्ट्री ऑफ टाइम फ्रॉम द बिग बैंग टू प्रीबायोटिक अर्थ। और आई एम वेरी हैप्पी कि आज हमारे साथ दो बहुत ही नौजवान और बहुत जहन मौजूद हैं। ऑन माई राइट इज़ शहरयार ज़ीशान। इनका प्रोफाइल इतना लंबा है, मैं दो चार जुमलों में कोशिश करता हूँ कवर करूँ। टेक वर्ल्ड में यानी वेब डेवलपमेंट, UI UX, ग्राफिक डिज़ाइनिंग वगैरह में काफ़ी एक्सपर्टीज़ रखते हैं। अदर दैन दिस आप एविड ब्लॉगर हैं, यूट्यूबर भी हैं, और कॉस्मोलॉजी में एस्ट्रोफिजिक्स और कॉस्मोलॉजी जो है इनकी दिलचस्पी के मैदान है। ऑन माई लेफ्ट इज़ शहरयार ज़ीशान। पैलेंटोलॉजी, जोलॉजी, बायोलॉजी जो है इनमें इनकी दिलचस्पी है। इसके अलावा मैथमेटिक्स को भी बहुत पसंद करते हैं। ओरिगैमी इनकी हॉबी है। गिटार भी प्ले करते हैं। रॉक और फ्यूचरिस्टिक म्यूज़िक जो है उसकी बीट्स पर सिर्फ सारी नहीं धुनते बल्कि रक्स भी करते हैं। मैं आपका मज़ीद वक्त नहीं लेता हूँ। आज का आप लोग इतनी बड़ी तादाद में आए हैं। इससे पहले जो सेशन हुआ था दानियाल का हुआ था, जो हम सब ने बहुत इन्जॉय किया। ये वाला सेशन मुझे पूरा यकीन है कि उसी तरह आप सबकी दिलचस्पी का भी मौजू होगा और हमें इन दोनों स्पीकर से सीखने को भी मिलेगा। लेडीज़ एंड जेंटलमैन, शहरयार ज़ीशान और शहरयार ज़ीशान, थैंक यू।
Thank you so much, Naya sir, for introducing us, and I am truly grateful to all of your audience, the TPH audience that have gathered here, and I believe so that you'll enjoy this presentation and will ultimately Yes. So you have gone through our introductions. So let us move on to the presentation. Yes. So on this auspicious day, we presented a tribute to our awe-inspiring personality, Dr. Prowess, and especially the cherished people of TBH. And this presentation will be on the common interests of the people of TBH. So let's get right into it. So Chronicles of Eternity, unveiling the tapestry of time from the big bangs to the prebiotic earth. We'll start from the big bang and go till the time of Homo sapiens, dinosaurs. So buckle up,
cause we are just getting started.
that's how the first eukaryotic organisms formed. So the vital question, the fundamental question is that why are we here?
Where do we come from? These are most enduring of questions.
That we are here and are, the purpose of human race on earth. So there are three main, you can say, standpoints that we can view this topic from. The first is the anthropological and the cultural factors, meaning that human beings possess a distinct skill of capabilities and abstract thinking, social cooperation, which have allowed us to create complex societies, cultures, and progress as one singular human race. Next is the evolutionary perspective. The human race exists on earth according to this standpoint due to natural selection and adaptation. Then there is the ecological, the geological and the environmental factors. The earth is the only planet in the universe that has the conditions to life, for life to withstand upon, and there are various factors. For example, हमारे सोलर सिस्टम में जुपिटर एंड सैटर्न जैसे गैस जॉइंट्स मौजूद हैं जिनकी वजह से एस्ट्रॉयड बेल्ट retained not only due to their gravity but also they protect us from extinction events. Next, the magnetic field of the sun creates a aura, or you can say a sphere that protects us from the gamma ray bursts of quasars and neutron stars that can be detrimental to life on earth. So you can say the presence of liquid water, the Goldilocks zone in which earth is, and then the adverse range of ecosystems and the atmosphere within the right composition have played a crucial role in shaping the development of life on earth. So basically what we are trying to say here कि अर्थ में वो सारी क्वालिटीज हैं जो लाइफ को चाहिए एग्जिस्ट करने के लिए. Next, we come to understanding the theory of Big Bang. The Big Bang theory explains the origin of universe, that it started as a singularity, and as of yet we don't know what caused the Big Bang, or was there any time, or was there any matter before the Big Bang. But for now there are many speculations and theories that relate to the fact that there was let's say a multiverse, that a black hole swallowed all of the mass and then imploded or exploded, causing the making of our universe. That could be one you can say speculation that led to the Big Bang. Finally, then we go on to the death of the universe, the ultimate fate of the universe. How will the universe end? And there are like the big freeze, the big crunch, dark matter and dark energy will vanish and gravity will overcome and everything will regenerate to a Big Bang, condense to a singularity, and then maybe, we don't know, it's a speculation, but implode again. This could be a theory. So then we come to a fine tuning problem. Why is the universe made for us, so called made for us, so called fine tuned for us, meaning that the apparent fine tuning of the universe for human existence is the subject of debate, we know that, and then the subject of explanations through the multiverse hypothesis, the selection bias, and the alternative forms of life. I know this can be overwhelming, but step by step I'll explain the multiverse hypothesis, the selection bias, the alternative forms of life, and the incomplete understanding, because we are observers, so it is the incomplete ness of our understanding. We have not observed the universe as a whole. We know that the observable universe is 96 billion light years in diameter, but beyond that we don't know what lies. Beyond that we don't know what is, maybe even alien life forms. So this is a topic of philosophical and scientific discussion, and each day we discover new things in it. Firstly, I'll explain the multiverse hypothesis. This is the idea that there are many universes, बहुत सारे यूनिवर्स हैं, बाय चांस हम उस यूनिवर्स में हैं जिसमें लाइफ के लिए कंडीशंस हैं, तो इसी वजह से लाइफ एग्जिस्ट करती है हमारे यूनिवर्स में. दिस इज व्हाट द मल्टीवर्स हाइपोथेसिस सेज. According to this hypothesis, our universe is among a number of universes, each with its different and physical properties. Every other universe has many other different physical properties. The science, the laws of physics do not apply to other universes as they do to our own universe. So this is the difference. Even this is still a speculation, but Stephen Hawking proved the theory of multiverse mathematically. Still, it's a mathematical speculation. So then they each with a different number of physical properties. In such scenario, it is not surprising. It is the luck by sheer chance game. If you roll a dice infinite number of times, ठीक है? If you roll a dice infinite number of times, ultimately you are going to get the desired probable outcome. So इसका मतलब ये हुआ कि हमारा यूनिवर्स फाइन ट्यून्ड लाइफ के लिए इसलिए है क्योंकि we have rolled the dice 100 of times, not we actually, some other forces you can say. So by sheer chance हम उसी यूनिवर्स में हैं जिसमें conditions right हैं life के exist करने के लिए. This is the multiverse hypothesis that we are going for. Then there is the selection bias or the observational constraints of humanity, meaning that our ability to contemplate the universe is inherently biased upon our existence as conscious observers, meaning that we do not have the tools, or we are not looking in the right direction. We are not utilizing our resources, as I might say, to let's say expand our reach to other planets and to look for life in a more vigorous manner. अच्छा, therefore the fact to ponder that question कि अगर इस universe में life ना होती, then there would have been nobody to ask the question कि why is our universe only that is having the life. So therefore that the fact we observe that a universe is suitable for life is not surprising. This often is referred to as the observer's selection effect or the anthropic selection effect. So this may kind of be like overwhelming and speculative to you, but these are well tested and certified theories by various scientists, and there has been a lot of debate over this theory. And overcoming this fact, I kind of find this postulate of this theory to be very counterintuitive. This is the third you can say postulate that is a solution to the fine tuning problem. Okay, we have not discovered any alternative or unknown forms of life other than the ones that exist on our planet. Okay, so the notion of the fine tuning problem assumes that life can only exist in specific conditions that we understand. कि जैसे हमारे planet पे life है वैसी हो सकती है. We assume this, right? So however, it is possible that life could have evolved on different forms based on different fundamental principles maybe in our universe or in another universe. For example, let me give you an example. On the surface of Titan, a moon of Saturn, yes, a moon of Saturn, there are oceans which have like frozen matter on top of them. Scientists believe that this could hold the silicon based life, meaning that our life is carbon based. Homo sapiens and every living matter on earth is carbon based. So scientists believe that on Titan there could be a silicon based life also. So by assuming that our form of life is the only possibility, we might overlook other potentials of forms that could arise in different environments. So this was what I was explaining. Then comes the simulation hypothesis. कि some other being has programmed our universe to be as it is. This can be seen as a possible solution to the fine tuning problem by positioning that our universe specific parameters and constraints are a result of intentional design or programming. However, it is important to know that both of the fine tuning problem and the simulation hypothesis remain so called speculative. Okay, this can't be proved. The simulation, we are in a simulation, this can't be proved, although there are various tests upon it that we can do, discovering so called glitches in matrix that we can go for, but so far so on we can't tell if we are living in a simulation or not, and that's what keeping me up at night, I think. That is what's keeping me up at night. So, and the subject of ongoing debate and exploration of fields of cosmology, physics and philosophy might further refine this topic of simulation. Then comes the most interesting part that you have all been waiting for, the Fermi paradox. It is the contradiction between the high likelihood कि life हो तो सकती है पर अभी तक हमें मिली नहीं है. This is the Fermi paradox, meaning that in the universe there is the absence or evidence of contact. There are no signatures of electromagnetic waves in the universe. We haven't, although there are some like exceptions that we have, gone upon some strange signals received, but that's still not a proof, not a solid proof. So, including the rare occurrence of intelligent life, limitations of travel and communication, and the self-destruction of civilizations by so-called factor like one civilization that existed before us may have developed AI, and that AI would have been cause of that civilization's destruction. But that's a topic I wouldn't adhere to touch right now. So, over here what you can really see is the Fermi paradox that we are alone in the universe, and this is kind of strange because universe is 13 billion years old, a lot of time for life to evolve previously on other planets, and there are beyond a billion galaxies in the observable universe, each with almost a billion solar systems, and then in these solar systems I think 10% have the capabilities that have a planet that is present in their Goldilocks zone. So, there could have been a lot of chance for life to evolve in these kind of conditions. But why don't we find life here? This is the Fermi paradox, and scientists are still researching on it. And next, I believe it is very important to invest in space exploration, and it is very important to depend upon the continued technological advancements and investments in research, development and collective efforts of governments, private companies and international scientific community, and explore the utilization of space, offer vast potential for scientific discovery, resource planning and expansion of universe beyond the earth boundaries. So, basically ये है कि we need to expand our boundaries, we need to invest in space travel. Not only, अच्छा, one more thing, people say कि why do we invest in space travel? And my answer to that is, why do we build ships that go on the sea? Okay, if we have so much to do on land, why do we go explore the ocean? The same philosophy applies to space travel. If you have so much to do on earth, why go explore? It may be a resource for, let's say, asteroid mining that can elevate your progress on earth, that can give you the basically the materials that you require to excel further on planet earth. That can be a possibility, aspect of this. And then there are black holes in the space. Those we haven't we have observed, we have taken two pictures of black hole. One is Sagittarius A, the center of black hole in our Milky Way. And then the other is like a black hole which was very near to our planet, but we magnified it so much, and there was a lot of science behind this. Scientists needed to build a telescope that was the size of Earth to observe a black hole. So, how do we overcome this? We plant telescopes in every region of our continent, many of the spheres of dominant influences on the continents, and then we project basically a image that can, and then we stitch that image together. That's how we got a image of first a black hole that was proposed by Einstein in around the 90s. So that's how fast technology is evolving, and I believe it has the potential to, you know, go beyond what we might not have even imagined 10 years before. So now comes the secrets of universe. The secrets of universe are vast and complex, but we have uncovered some of the fundamental principles through scientific observation and experimentation. We know that the universe is expanding and composed of dark matter and energy flows and the laws of physics, yet there is still much more to be discovered and understand about the origins, composition and the ultimate fate of the vast cosmos. So here one thing I would like to basically go on and predict to you, there is 5 times more dark matter or dark energy than there is normal matter. So if there was even let's say 4 times more dark matter, life could not have been possible on planet Earth. So isn't it fascinating that 5 times more dark matter or 4 times more dark matter contributes to the existence of life on planet Earth. So that was what I wanted to go upon, and this is very interesting. The universe has set numbers. This is not the only constant, it's just an example. There are hundreds of other constants that contributes to the existence of life, and even in points, if one of those constants is disrupted or dislocated, the existence of life would not have been possible on Earth. So it's human nature to wonder, why on Earth, why are we special? But this is quite counterintuitive, that when the model of solar system was proposed, geocentric model, the Earth is in the center and then sun revolves around the Earth. This was a wrong concept, everyone knows it right now. So even if we scale this concept to the level of the universe, we might discover that we are not the only one living in the universe. This is a huge grain of salt. So now comes the entropy and the arrow of time. So entropy is linked to the arrow of time and the second law of thermodynamics. The second law states that the entropy tends to increase over time. One very interesting example I find, if you leave your bedroom alone for a while, the entropy is to increase. If you don't interfere in that system, the entropy is to increase. So same law applies here on the universe. That's just a simplified example. So then as you increase time, the progression leading from a lower entropy, which means greater order, to a higher entropy, which means greater disorder, is very much likely. So the directional flow of increasing entropy aligns with the arrow of time. कि जैसे जैसे वक्त आगे बढ़ता है, the entropy increases. So we observe this process in moving as referred to temporal direction, which means temporal means related to time, and that direction, obviously the arrow of time goes forward. So entropy, I think entropy defines the arrow of time. A pause there, point to ponder for you all. So the irreversibility of certain events driven by the increasing entropy of closed system establishes the connection between entropy and the one-way flow of time, giving rise to the arrow of time and its fundamental asymmetry. And we can prove this through the second law of thermodynamics. That's the gist of it. Now my brother will drive you through the origins of paleontology.
So basically, What is paleontology? Paleontology helps us understand the origins of life on Earth by studying prehistoric fossils and learn about extinct species and ecosystems that existed millions of years ago. So, journey through Earth at time. Earth is 4.6 billion years old, and it has been through many geological eras such as the Paleozoic, Mesozoic and the Cenozoic era. Each era has its own unique geological events, ecosystem and life forms. So, dinosaurs. Dinosaurs, the name dinosaurs comes from Greek, from the word dinos, which means great, terrible and fearful, and sauros, reptile or lizard. Dinosaurs were a diverse group of reptiles that lived millions of years ago during the Mesozoic era. They ranged from size from huge to large, and they included carnivores, herbivores and omnivore species. They had reptilian scales, long tails and three-toed feet. They laid eggs, but now they are extinct. But their fossils provide valuable insight on the Earth's past. So, the evolution of life on Earth. From a single-celled organism to complex life forms, the trace of evolution of life on Earth through fossils, record timeline discover how life has changed over billions of years. So, the extinction of dinosaurs. So, the most widely accepted theory of extinction of dinosaurs is that an asteroid collision with Earth occurred 66 million years ago, which led to chain reaction of events which led to the demise of the dinosaurs. So, importance of fossils in paleontology. Why are fossils so important in paleontology? So, fossils are an essential tool of understanding the history of life on Earth. They provide evidence how species changed over time, from single-celled organisms to complex dinosaurs.
Now, here comes Charles Darwin. So, he was an English naturalist known for his theory of evolution by natural selection. In his book On the Origin of Species, his work revolutionized biology and continues to be influential in the scientific inquiry. So, here Darwin's work is, I think, a puzzle, a great piece of puzzle that he solved that no other person at that time could. So, it was a piece of puzzle that only a great mind like Darwin could solve. So, Darwin's extensive travels and observations provided the basis for his groundbreaking theory, which is that every single organism has evolved from a single-celled prokaryotic organism and further onto the eukaryotic, and then finally complex organisms emerge. For example, lizards, reptiles, and then they further evolve. And then they further evolve into aquatic, dinosaurs, and then
first was aquatic, then was lizards, then was dinosaurs.
Exactly. Then, then finally we as apes emerged, and then human race was evolved, and Homo sapiens. Acha, there is a theory that Homo sapien has killed 7 other species, that Dinosaurians, Neanderthals and such 7 names that they needed to kill in order to survive. So, we must thank our ancestors for killing the other apes because due to that killing our survival depended on that, because if they were here they might have overtaken us then. So, thank you for joining us on our journey through space and time.
And let the Q&A begin.
Yes. Thank you. And also one more thing, I would like the TBH audience to subscribe to our YouTube channel, The Twilight Zone. No intent of self-advertisement though. Thank you, sir.
Thank you, sir.
Thank you so much. Sir.
And I'm glad at this young age you have accumulated so much, and your curiosity and level of interest and the confidence that you display is really impressive.
Thank you so much.
So it was a pleasure being here, and I'm sad also that you are leaving and going to to Lahore.
Thank you, sir. Heartiest thanks to you. And we are really great to have your presence here. We are honored actually.
Thank you very much, Shehryar and Seljuk. I had a great time and amazing presentation. So let's talk about the Fermi paradox first. So one possibility can be that there might only be carbon-based life spread across the universe, but as far as I've read, we don't have powerful enough telescopes to peer right into the atmospheres of different planets, okay? And the extent of the planets we have discovered so far are only within a small radius around us within the Milky Way galaxy. We haven't even discovered all of the planets inside our own galaxy, let alone other galaxies. So there might be lots and lots of life out there in other galaxies. Our range is currently very, very limited. So I think it's very premature to say that the Fermi paradox is actually a paradox, that we haven't discovered life. Because we could only say that when we would have peered into most of the planets that exist in our observable universe, right? So far, we've only discovered very, very few. And for example, in planets that evolve intelligent life, only on those planets can we expect to see signs of life. For example, if there are planets around us, but they only have kide-makode and microorganisms and little like rats scurrying around, then we can't expect to observe them from so far, right? We can't even, for example, even from our International Space Station, if we peer down into the Earth, it is very, very difficult to discern life, even from the internet, which is only 100 kilometers above the surface. Even from that perspective, it is very difficult to discover that there are life forms on the Earth. So it is extremely difficult to discover life on planets so far away. Right, and the nearest star to us is 4 light years away, which is an immense amount of distance.
Proxima Centauri.
Yeah, so I think we shouldn't call it a paradox yet. It's a problem, and it's an open area of discovery.
Right. I completely agree with you. So, sir, as you said, the Fermi paradox. Acha, so there is one thing, the telescopes that the ISS, the James Webb Telescope, are orbiting around, they are near to Earth. The James Webb Telescope orbits in L2, which is an orbit around the Sun. So, I think it is very much necessary to send probes like Voyager 2, sent by Carl Sagan, away from the planet Earth, so they can actually, enter the, if not enter, then closely peer through other planets' atmosphere. Thanks to the telescopes mostly sent by America, we have discovered a series of planets that are named Kepler. There are a lot of a whole series of planets, and they are very similar to Earth in a lot of ways. The size is different although, but they have the atmosphere, they have oxygen in their atmosphere, which is a great sign. And even if the planet atmosphere is not present, even if the planet doesn't even have a magnetic field, still it can have life. I would like to extend my, prove my, discussion by saying tardigrades.
Yes.
They can survive in vacuum without oxygen.
Tardigrades were sent on an outside of a rocket ship to which circled the Earth for 17 to 20 minutes, and when they came back and observed the tardigrades, they had actually had babies. Not they had not died, they actually reproduced. So this life, if it can survive in outer space, why can't it survive on other planets?
Yes, but in that case, we would need conditions first to evolve tardigrades, right? Because tardigrades, compared to eukaryotic cells, they are still very complicated.
Yes.
So first, you would need to have conditions for eukaryotic cells to evolve. You would need to have liquid water, and then after a few, like hundreds of thousands or millions of years, then tardigrades would have evolved, right? They wouldn't just come out of nowhere.
Yes, exactly. You're right. So, anyone would like to comment upon dinosaurs?
Yes. My second comment was about dinosaurs. I would like to direct my second question to Seljuk.
Exactly.
So yes, the asteroid theory is the most accepted theory, but if you read about the recent research, right, the most latest research, now scientists are saying that in addition to the asteroid, other events were also taking place on Earth 65 million years ago.
Like
and
volcanic eruptions.
yes, the main event that they point to is the super volcanic eruption in the Deccan region in India, here right beside us. So we have evidence for this, that right around that time, large volcanoes, super volcanoes erupted, and they spewed a lot of matter into the atmosphere, which cooled down the earth and also led to a large amount of pollution. And concurrently to that, an asteroid also hit in Mexico in the Yucatan Peninsula. So 2-3 events, major events, all of them contributed to the demise of the dinosaurs.
Yes, as I said in my presentation, that the most widely accepted theory is the asteroid impact that occurred 66 million years ago, which also caused a chain reaction of events that led to the dinosaurs' demise. First of all, there was an asteroid struck that created basically like a shock wave around the earth, wiping out most of the life. Then there were volcanoes, tsunamis, and more natural disasters that wiped out rest of the life. But somewhat really few microbes or cells and some animals did survive, which later evolved into us life, which was then after the great extinction created the life we know today.
Exactly. And another interesting fact is that since we are mammals, then some mammals should have survived during that
Yes,
event,
some
right?
mammals did
And the
survive.
only mammals that survived during that time were types of rodents. So basically, we have evolved directly from something of like a rodent type creature. So that is also an interesting fact, not just apes. And people mind this a lot when I tell them this fact that did we evolve from rodents? But it's logical, because rodents were the only thing that survived after that event, and since we are mammals and rodents are also mammals, we directly evolved from those kinds of animals.
I have one comment regarding you described Neanderthals and Denisovians. These were actually Homo Neanderthals, Homo
erectus.
Denisovians. And one theory is this, that those species mixed with the human being. That human being also, because we have done the genome project, and in genome project we have found their DNA is mixed in our DNA.
Only Neanderthals.
And also Denisovians also.
Some part.
Some part lies in our DNA. So there is a mixture of them. Again, means if there is a common ancestor behind for that, and then this Homo sapien species mix those and capture those species inside them. This is one thing. And other thing regarding dinosaurs. You know, there is one theory regarding birds, that birds are actually evolved from dinosaurs. Birds are living dinosaurs. In today's, maybe all dinosaurs didn't vanish. So these, due to scarcity of food and change of environment, those evolved into birds. This is one more.
Well, basically, this is also partially true, that some of the smaller dinosaurs and the smaller reptiles, some of them went back into the water to form crocodiles and other modern day these lizard species, and some survived on the land, and then they developed wings to fly, which turned into modern day birds.
Okay.
Acha, there is one more thing. As we see in the movies, dinosaurs have scales. They are sharp and very much ferocious predators.
Okay.
But some kind of dinosaurs actually had feathers, and they were like very
Furs. Those have furs.
feather and fur,
Furs.
both.
Both,
Okay.
both.
Both. And then basically those dinosaurs were in for that fact they were resembling chickenish look. Yes. So to change your point of view upon dinosaurs as apex predators, so called ferocious and very much sharp and those kind of like dangerous creatures, they could have been very much chicken like creatures. So still very big, yes.
Monsters. Yes.
Why do we assume that it was good for us to kill all similar species like Neanderthals and all? Maybe if we had not killed them, maybe we could have learned to live together peacefully, just like we are living with so many other species, much more ferocious animals. So why are we assuming that it was good for us to kill them?
Well, it was good for us to kill them, as if not, there was actually basically like a type of war between all the species of humans, all the species of Homo sapiens, and all those had like a war between them. They were warring tribes, so they would wipe out each other. So for the most intelligent of them would survive. Only the one that can adapt to its surroundings the most quickly will survive.
Yes. Acha, and
Survival of fittest. Survival of the
and
fittest.
also their like Dinosaurian and Neanderthals had very high IQs, and their IQs were closely related to that of ours. So they were a more bigger threat to us than, let's say, cheetah or megalodon or not like great white shark, those kind of things. The Dinosaurians and Neanderthals were a much bigger threat to us than the apex predators, because they had the intelligence, and we believed that if we don't kill them right now, they might kill us back another time. So our ancestors might have found this very much productive to kill them, very much against non-violence.
Hello Shehryar, I'm so interested in multiverse. Might be there is a copy of me somewhere in the universe. तो इस पे आप क्या कहना चाहेंगे?
Sir, is that copy more intelligent than you?
I don't know.
Yes. So these kind of paradoxes arise when we say that there is another copy. Your question is very much similar to the paradoxes that arise when we do time travel.
Like the grandfather paradox.
We have not seen another universe, excluding our universe. We have not even up to got to point to explore our own universe. So it's just a theory proven by mathematics that there are other universes. And you're right, and there are lots of ways to define a multiverse. There is one thing that there is a copy of you. Other theories say there is not a copy of you, there is like an other creature or another civilization in each universe, or maybe other universes are just lifeless. These are all possibilities जिसके ऊपर हम we can discuss for hours. So sir, I hope that answers your question. Thank you.
Thank you, Shehryar and Saljok. Very interesting, and When we talk about evolution, simply we usually miss the nuances between the transition. For example, we usually said we have evolved from monkeys. There is a huge period from
between.
evolution from monkeys to humans. Maybe we usually use the evolution, who believes in evolution. These are huge debates on it. People say that in one words, we have evolved from evolution, from
Apes.
monkeys, apes. Reptiles, birds evolved from reptiles. And if we go the book, for example, the recent books of, not recent but the very famous books, Yuval Harari, the Sapiens, Origin of Sapiens and Humankind. These are very famous books, and everyone quoted these books about human origin, and he talked about agriculture evolution, industrial evolution, and then we. Now the debate has in one sentence or in one paragraph, we just concludes 1.5 billion years of events. We just say that is industrial revolution, then this, for example, agriculture revolution. And between that period, these are nuances. And I would recommend you to further explore the very, very sub-stages of evolution. That will give you the other aspects and the other dimensions. Maybe you discover the gaps. This is still under debates. That we can't say that we just evolved from monkeys based on DNA, based on some other. There is a huge gaps, huge lot of data are still missing, and people and students of history like you should explore these area. I would recommend you.
Sir,
And like, for example, the birds evolution from reptiles. There is one species we all know, Archaeopteryx. Some of their character are similar to reptiles, and some of their character are similar to birds. And that there's a very Seljuk, fossils, very famous fossils. Transition between reptiles to bird, Archaeopteryx.
Yes.
So based on this similarity, people say that some are the character are similar to birds and some are similar to reptiles. That is why we can say that birds are evolved from reptiles.
As
So in the, I would like to just say one thing. Sorry, it's getting long. You people should explore the nuances between. For example, we have divided epoch, which is era 1.5 billion, then 2.5 billion. Between 1.5 billion to 2. There are lots of events have occurred. We just one stroke of line said industrial revolution, agriculture revolution. It is not like that. So I would recommend you to study to learn about it. Thank you.
thank you, sir.
Sir, I'd like to comment upon your as the dinosaur kingdom has basically two major parts: bird-hipped and lizard-hipped. The lizard-hipped were like partially amphibians, so they could go back into water, which are the crocodiles of today. And the bird-hipped formed wings and started to fly, which we are calling birds today. So these two kingdoms were basically, so we say dinosaurs as a whole, including these both kingdoms that were inside of this huge dinosaur kingdom. Some of them did survive from each kingdom, which later some mammals and rats also survived, which were huge at that time, which they shrank due to the food shortage after the great extinction. For like there were very less plants, so they slowly and steadily evolved over the millions of years, which you are saying that we need to more know about the more events that happened in between these years, between the main points, the great extinction and the agriculture evolution of humans from apes to modern humans.
Sir, I would say that you are completely right that there is a lot of missing data, but science says कि आओ सवाल पूछो. Not like let's say the religion is our belief, right? It kind of prevents us from asking questions. There is a difference between those kind of two things, and we must not amalgamize them. So science says कि let's go for a logical argument, and I'll go through the resources that you recommended me, and you know, I'm open to discovering new things, so I'll definitely, you know,
Thank you.
attend you.